Hi, it's Valentine from Simplistic, and in this video, we're going to take a look at a problem where we're given a certain amount of sodium hydroxide and it's titrated with nitric acid, and we have to calculate the pH after the addition of a certain amount of nitric acid. Then we have to calculate the pH at the equivalence point, and then we add some more nitric acid beyond the equivalence point and calculate the pH again. Okay, so the first thing we need to understand is in this problem, they've given us a base and an acid, and the base is a strong base and the acid is a strong acid, which means there's no equilibrium. Okay, so what we need to understand from this is that because there's no equilibrium, we don't have to create any ice tables. We literally take everything at its face value. Okay, so to answer the first question, to calculate the pH after adding 30 ml of HNO3, the strategy is going to be we simply have to figure out how many moles of sodium hydroxide is there in this volume and this concentration, and then how many moles of HNO3 is there in this volume and this concentration, and then once they neutralize each other, how much is going to be left. Okay, and that contributes to the pH. So let's go ahead and do that. So the moles, the first thing we'll write is moles of NaOH. That is equal to 50 ml. We want to convert that to liters, which is going to be 0.0 excuse me 050 liters times the concentration, which is going to be 0.200 moles per liter. That is going to give me the number of moles, which ends up being 0.0100 moles. The next thing we want to do is find out the moles of acid that were added. Moles of HNO3 added. That's going to be, again, we convert the volume 30 ml to liters, so that's 0.0300 liters times 0.200 moles per liter of acid, and that is equal to 0.00600 moles. All right, so once we have the moles of acid and base, now we have to just subtract the two. So if I just subtract the two, I get 0.00400 moles of, so this is the excess base. All right, so once we know the excess base, we have to calculate the new concentration of base. So new concentration of NaOH, which is going to be the moles divided by the volume. So that moles divided by the new volume, which is going to be 50 ml plus 30 ml. So that's going to be, divide that by 0.0800 liters, and that gives us a concentration of 0.05. We can add some more zeros out there, molarity. Okay, so now since we have to calculate the pH, and since NaOH is a strong base, all the OH minus ions in solution, so that gives us OH minus ions in solution, all the concentration comes from the initial concentration out here because all of it dissociates. So that's going to be 0.0500 molar. So to find the pH, we have to calculate the pOH first, which is going to be negative log of 0.0500 molar, which is equal to 1.30, and then the pH is going to be 14.00 minus 1.30, which is equal to 12.70. And that is the answer to question A, part A. The next question says, what is the pH at the equivalence point? So this one doesn't really require us to do anything, because at the equivalence point, the number of moles of nitric acid equal the number of moles of sodium hydroxide. Therefore, the pH has got to be, since they equal each other, they neutralize each other. Therefore, the pH has got to be 7. So we write pH is equal to 7.00. All right, and the last part of the question is, they're saying after the addition of 60 ml of 0.200 molar nitric acid, what happens? What is the pH? So all we have to do is calculate the moles of nitric acid in 60 ml. That is going to be equal to 0.0600 liters times 0.200 molar, which is equal to 0.012 moles. Let me go ahead and add a few more zeros out here. All right, so the moles left is going to be, since the total, the maximum moles of NaOH is 0.010, the moles left is going to be, we got to subtract 0.0100 from this. That's going to be 0.00200 moles. Now we have to make that into a concentration. So the total volume at this point in time is equal to 50 ml of the base plus another 60 ml which was added of the acid. So that is 110. ml. We convert that to liters. That's going to be 0.1100 liters. So the concentration is going to be moles over liters. That's going to be 0.00200 divided by 0.1100, which is equal to 0.01818 molar. The pH, now since this directly is the H3O plus ion concentration, because HNO3 is a strong acid, so all of it produces the H3O plus ions in solution. Therefore, the pH of this is going to be simply be negative log of 0.01818, which is equal to 1.74. And that is the pH. All right, I hope that made sense. Thank you for watching.